Here is a video about shell and washer method. So here's the setup. We have the functions y equal to x squared and y equal to 4x. We want to take the region bounded by them, which is right in here, and revolve it around the x-axis on this side. We'll do the y-axis on the other side. And we want to talk about how you could either use the shell or the washer method to calculate that. So first let's talk about the washer method. So if I'm going around the x-axis, my strip has to be vertical because it has to be perpendicular to the axis of rotation. So my strip being vertical, my large radius is the function that's further away, which is y equal to 4x. My small radius is the function that's closer, which is y equal to x squared. Also, sorry, I should back up 1 second. Over here is the work to find what the points of intersection. You set x squared equal to 4x. You bring the 4x over to the left, you factor out an x, you get x equal to 0 and x equal to 4. So the points of intersection are 0, 0, and 4, 16. And then if you didn't want to graph it, you could see that 4x was the function that's further away by plugging in a point between 0 and 4, like 1. If you plug in 1, 1 squared is 1. If you plug in 1, 4 times 1 is 4, and 4 is bigger. So setting up the washer method, the volume is going to be the integral from 1 to 4, right? That's from x equals 1 to x equals 4. And we know it's x because we know we have a vertical strip. And if there's a vertical strip, it's a dx. So it's going to be pi times the big radius squared minus pi times the little radius squared. And that's it. And then, you could factor out the pi and have the integral from 1 to 4 of 4x quantity squared is 16x squared. X squared squared is x to the 4th. And then you would, oh sorry, the lower limit should be 0, not 1. I don't remember 1 there. Sorry. So we're going to get pi times, integrate this, you get 16x cubed over 3 minus x to the 5th over 5. And then when you plug in 4, you get some gross numbers. You get, actually, so if you're going to get 4 cubed, 16 is 4 squared, so you're going to get 4 cubed is 4 squared, which is 4 to the 5th over 3 minus 4 to the 5th over 5. You can factor out 4 to the 5th, which is 2 to the 10th, which is 1,024. And you're left with a 1/3 minus 1/5, which is 5/15 minus 3/15, which is 2/15. So you get 2/15 times 1,024, which is 2,048 pi over 15. Kind of gross, but oh well. All right. Over here, using the shell method, we have to use a horizontal strip, so it's parallel to our axis of rotation. So then the radius is the distance of the strip from the axis, which is just y, because it's horizontal. If it was a vertical strip, it would just be x. But our radius is y. And our volume is going to be the integral of 2 pi r h dy, where r is given by, again, just y. And that's your radius. And the height is given by the length of this, which is the right minus left if it's horizontal, or top minus bottom if it's vertical. So it's going to be the square root of y, or y to the 1/2 minus y over 4. Okay. I suppose, oh, and the limits of integration are going to be from 0 to 16. And suppose we should calculate this since we calculated the other one. I'm going to erase the other one so we can do the calculation here. So we're going to end up with, it's kind of gross, integral, let's bring the 2 pi out in front, from 0 to 16, of y times y to the 1/2 is y to the 3/2, and y times y over 4 is y squared over 4, or 1/4 y squared. Okay, integrating, we get 2 pi, y to the 3/2 is, integral is 2/5 y to the 5/2. This is going to be y cubed over 12 from 0 to 16. The numbers are not pretty. It's 2 pi times 2/5 times 16 to the 5/2 is the square root of 16, which is 4. 4 to the 5th is 1,024. And then 16 cubed, blah. 16 cubed, let's just write 16, oh my god. Sorry, the numbers are getting gross here, but it is going to end up being the same. So 16 cubed is 16 times 16 times 16 over 12. I'm not worrying about the 0 because plugging 0 is going to be 0. I can cancel a 4 here and a 4 here. So this is 2 to the 4th times 2 to the 4th times 2 squared, which is 2 to the 10th. So this is also 1024. So I can factor out 1024 from each of the, sure. So I get 2 pi times 1024. I'm left with a 2/5 here, minus, I factored out everything, so I'm just left with a 1/3 here. I'm a little bit worried it's going to come with me different. Let's see what we got. So 2/5 minus 1/3 is, multiply this by 3 by 3, 6/15 minus 1/3 is 5/15, which is 1/15. So we're good because 2 times 1024 is 2048 pi over 6/15 minus 5/15 is 1/15. So over 15. Same as the other side.